we have two options for deriving the double angle formula for tangent. In a moment, I'm going to have you pause the video and use both of them, and I want you to see if you can simplify them to get the same formula. Okay? So the first option is to say tangent of 2 theta is tangent of theta plus theta. Again, make that brilliant observation, and then we can just plug into the sum formula for tangent. Okay? Now, I would recommend, as you're watching these videos, any formulas that we're using that you have not memorized. Now, you should be at a point where you either know them or you know how to get them. But there might be some that you prefer to derive rather than having memorized. And there may be some that you're in the process of memorizing and don't have yet. Okay? Keep a list with you. Normally, when I'm lecturing in a big classroom, I would have all the formulas that we need for reference on one side of the board, and then I'd be doing my work over here so I could sort of point to those formulas. I just don't have enough room to do that with this small board that I have here. Okay, so I'd recommend that you have a list of any formulas that you need for reference really handy as you're watching these videos. All right, so I'm going to have you do that. That's going to give you a formula that will be in terms of tangent. Okay. The other option that we have is that tangent, of course, is sine over cosine. So tangent of 2 theta is sine of 2 theta over cosine of 2 theta. And we just learned double angle formulas for sine and for cosine. Okay. So you can use those and plug in. Then you'll get a formula for tangent of 2 theta, but it will be in terms of sines and cosines. See if you can simplify that to write it in terms of tangents and make it match the version that you got here. Okay? So pause the video, give that a shot, tune back in, and we'll work through it together. Okay, I did just remind us here what the sum formula for tangent looks like. So if I'm copying that, replacing both u and v with theta, I'm going to get tangent of theta plus tangent of theta over 1 minus tangent of theta times tangent of theta. And of course, I can then consolidate some things and write that as 2 copies of tangent of theta on top over 1 minus tangent squared theta on the bottom. Okay, so that is the formula for tangent of 2 theta that we're going to have that expresses it in terms of tangent. Let's see if we can get that using the double angle formulas for sine and cosine instead. Now, in the interest of space, I didn't remind you of these formulas separately on the board because I'm about to write them right here. We saw that sine of 2 theta was 2 copies of sine theta cosine theta. Now, with cosine of 2 theta, we had 3 options for the version that we could use. I'm going to go with the one that fell right out of the double angle formula for cosine by plugging into that directly without doing any additional manipulation using the Pythagorean identity. I'm going to do that because I know that I got the double angle formula for tangent by using just the double angle formula as it was for sine and cosine. So that was cosine squared theta minus sine squared theta. Now, if you used a different version of the double angle formula for cosine, you didn't do anything wrong. I just think this is going to be the easiest one to manipulate to make it match what we have here. But the other ones are equivalent and can be manipulated to make them look like this. Okay, so I said I wanted to get this in terms of tangents, and so with tangents I've got to have cosines in the denominator. So I'm thinking I want to divide through by, I'm thinking a cosine squared, okay? So I'm going to multiply by 1 in the form of 1 over cosine squared theta over 1 over cosine squared theta. I'm going to need 2 of them because that will cancel the 2 of them here, and that gives me 2 to pair with the 2 sines here to get 2 factors of tangent. All right, so let's see. I'm going to just move over here. So this becomes 2 sine theta cosine theta over cosine squared theta. What I'm going to do is I'm going to write that cosine squared as cosine theta times cosine theta. That way, this is just the top of my fraction here, but I can cancel one of those cosines with the other cosine, and the other one I'll pair up with the sine. I can see that's going to become a tangent. Okay. And then here I've got to distribute that over the subtraction. So we'll have cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. So let's see, what does that give us? Okay, that top of that fraction now is just 2 tangent of theta. Cosine squared over cosine squared is 1. Sine squared over cosine squared, that's tangent squared theta. So we are able to get the same formula. I think it was a little bit faster if we wanted it in terms of tangent to use the sum formula for tangent. But if that's one that you have chosen not to memorize, knowing the sum and the double angle formulas for sine and cosine, which fall directly out of those sum formulas, did allow us to get there as well. Good stuff.